We spend all day typing, clicking, and tapping away on our devices. But behind every single one of those tiny actions is this. Well, this invisible symphony. It's a secret process that makes everything work. So today, we're going to pull back the curtain on one of the most fundamental, most important parts of that whole process.
I mean, really think about it. You press the H key, and an H just pops up on your screen. It feels so simple, right? Almost instant. But what's actually going on under the hood in that tiny fraction of a second? Well, let me tell you, it's a way more complex and fascinating story than you'd ever guess. So get this, that key press isn't just sending a letter. It's sending a powerful signal that basically shouts at your computer's processor, demanding its full, undivided attention. It literally forces the processor to stop whatever else it's doing and just listen. Right, so this powerful signal, it has a name, and honestly, it's the real hero of our story today. It's called an interrupt. Let's break down exactly what that means.
Okay, so here's the official definition from the source material. An interrupt is a signal, plain and simple. It can come from your physical hardware or even from a piece of software, and its whole job is to force the operating system to just pause and figure out what to do next. It's kind of like your keyboard tapping the processor on the shoulder saying, "Hey, I need you for a second."
Now, what's really interesting is where these signals come from. They come from two totally different worlds. On one hand, you've got your hardware interrupts. That's the physical stuff. Your keyboard shouting, "Hey, a key was just pressed," or your mouse sending a signal. And then on the other hand, you have software interrupts. These are generated by your programs, usually when they hit an error or need to ask the operating system for a little help. To really get a grip on how this all works, let's use an analogy. Imagine your computer's processor, the CPU, is a master chef in a super busy kitchen. This chef is focused, working on some big, complex main course. That's your main program running. Then, all of a sudden, a waiter rushes in with a new, urgent order. That waiter? Yep, that's the interrupt. So what does our master chef do? It's like this elegant four-step dance. First up, suspend program. The chef carefully puts down what they're doing, marking their exact spot in the recipe. Step 2, transfer control. They turn their full attention over to the waiter. Third, they execute the handler, which means they quickly whip up that urgent order. And finally, once that's done, they resume the program. They go right back to their main dish, picking up exactly where they left off without missing a single beat.
Okay, but that's the crucial question, isn't it? I mean, a key press needs a different response than a mouse click, which is different from a network error. The chef can't just guess. There has to be a system, right? Some kind of index for all these different urgent orders.
And this is the brilliant solution, the interrupt vector table. Just think of it like the chef's special cookbook, a master index of quick service recipes. When that waiter brings the order, the interrupt, it comes with a number. The chef uses that number to instantly flip to the right page in the book and find the exact set of instructions, which is technically called the interrupt service routine. It's what makes this whole thing ridiculously fast and efficient.
All right, so that's the how. We get it. But what about the why? Why is this power of the pause so fundamental to computing? I mean, why go through all this trouble? Well, this simple mechanism is the very foundation of the modern multitasking computers we all use every single day.
Here's the deal. Interrupts are the secret sauce to multitasking. They're what allows the processor to juggle dozens of things all at once. It's why your mouse moves smoothly while a video is playing in the background. It's why your whole system feels so responsive. It's just an incredibly efficient way to handle everything from your typing to unexpected program errors, all without the entire system just grinding to a halt.
Let that sink in for a second. Without this whole system of interruption, your computer would be so frustratingly slow and linear. It would have to completely finish one task before it could even check to see if you'd pressed a key. It'd be like a chef who has to finish a 7-tier wedding cake before they can even look up to see that a waiter has walked into the kitchen. Just unusable. And you've got to understand, this isn't just some clever trick the system uses every now and then. This is the fundamental way your computer operates, every single second that it's turned on.
This quote from our source material just nails it. We live in an interrupt-driven world. Your processor isn't just chugging along working through one long to-do list. No, most of the time, it's actually just waiting for the next signal, the next interruption, to tell it what to do. So the next time you press a key, remember this. You're not just typing a letter. You're conducting a single note in that invisible symphony.
It's this beautiful, complex, constant performance of interruptions that your computer is orchestrating flawlessly, millions and millions of times a minute.
It really makes you think, doesn't it? This one simple, elegant idea, the interrupt, is what separates a basic calculator from the powerful, multitasking machines we can't live without. Seriously, without it, our modern digital world just wouldn't exist as we know it.